Hello. Hello. Good morning, evening, afternoon, etc. Hope everyone's having a good Wednesday. I just had apologies for the slightly later start. It was a thing that came up that meant I was preoccupied for 30 minutes prior to starting. Thank you for being understanding and still coming along. I also, interestingly, in that 30 minutes, well, just before the stream started, I completely locked myself out of my router, which was exciting, and then the internet went down. So that was a mad rush for the last 2 minutes, so I'm a little bit stressed. I have nothing set up, my environment's not set up, literally nothing. I looked at the time and I was like, I need to go live in 5 minutes, and nothing is working. So you just bear with me a second while I sort out various parts of my my setup. Which is exciting. Watch me do it live. Literally have. I don't even know what I'm doing. Right. I don't even have like a web browser up or anything. Might need one of those. Move that off screen. Apparently I'm live. Excellent. Glad everyone's here watching me flail around with this. Well, I'm trying to set up separate VLANs for my various IoT devices, and I was like, oh, because that sounds like a sensible idea. And I was like, I'll just try and patch this through to where my Home Assistant lives. And yeah, I don't know what setting I clicked, but all of a sudden, everything disconnected from the internet in the house, and I couldn't log into the router to undo whatever I'd done. So that was a mad scrabble. Worryingly, the only thing that could then connect to the router was the IoT network. So for a very short period of time, all of the cheap IoT devices I have in my house were the only thing that was able to have access to my home network, which was exciting. I would say 100% the opposite of what I'm trying to achieve, but here we are. Right, CD projects game, I think that's what we call it. We'll start with fish, and then we'll tmux, and then we'll split, and then we'll rename this one build, and then we're going to build, and then we'll do like what source game. Sorry, let me just bring this up. Here we go. Right, I think we're here. I think we're doing it. I think we're gaming. Right, okay. Exciting. Hey, hello, everyone who is here. Sorry, I normally do the usual shout outs, so I guess thank you everyone who has come along. Moose, Mario, Julian, Quecco, Pew, Connor, AC. Glad you're all here. Apologies for the mess. Okay, I've been thinking quite a lot about this. Okay, specifically I think my camera's a little bit too high. Hang on. Nailed it. What's dangerous? My miserable home network setup, or trying to move the camera whilst I'm streaming, or thinking. I don't really know which. Lots of the thinking. Yeah. Okay. Well, this is it. I've had thoughts. This is great. Okay, I'm pretty pleased with this. We have 3 barrels, and they interact with us in interesting ways. One moves with us, one moves in the opposite direction for us, and one remains static, as is evidenced here. The next ones I want to do are more complex. So I want to add one more, which is you only get the interaction when you are within a certain distance. So if you step away from it or manage to move it away from you, you'll stop interacting with it. And the other one I want to do is it only works if you can view it. So if it's in your view frustum, right? So I was thinking, well, those sound great, but I'm going to want like combinations. So I want to want like this one here that moves right. I'm going to want like with us, I want that when it's within a certain distance. I'm then going to want one that's within a certain distance and moves the opposite way. I'm then going to want one that's maybe over a certain distance and does that. I'm then going to want one that's like, when I see it, it moves with me. When I don't see it, it moves with me. When I see it, it moves the opposite to me. One's if I want like, when I'm not looking at it and I'm within a certain distance, then it moves the opposite way to me. Can you see how these are starting to like feel a little more like composition? So at the moment, what we have is nothing. Hang on. echo kilo disable. Right, so at the moment we've got is transformer? Nope. Object transformer. Okay, so the moment we've got this, right? I genuinely think this is okay in the sense that this will work. Okay, we can have, you know, the camera object transformer. We can have something like the inverse one, and we could. It's not a lot of logic. Okay, we could just duplicate this and just keep adding more. It's not great, but it's also not terrible. It will get us where we want to go, and the whole point of this is to get us where we're going to go. However, like every problem I have, I think this is solvable with templates, and I think what we want is something called sometimes called like the chain of responsibility pattern. I kind of want a pipeline of transformers, and each one has the option to basically proceed it to the next one. So we could say, hey, visibility transformer and distance transformer and then inverse camera transformer all chained together. And if each one's like, yep, I've passed my tests, the next one can have a go. And at any point, one of those can be like, nope, you're done. Here's your final delta. Yeah, it'll be frustum culling to do the visibility check, I imagine, to start with. There's also like occlusion queries with OpenGL, but that sounds a little bit more complex than I'm willing to kind of delve into at the moment. I think we can probably get quite far with frustum culling. So yeah, what I'm thinking is pipeline, right? A chain of things, and then each one can kind of progress through the logic, and we can basically build up the complex logic from primitives. What I really want is like this, this little bit here, encapsulated in one place and be as like a reusable component. So I think I'm gonna have a go today. My goal for today is to have a go at refactoring all of this logic into a more composable pipeline of things. And I think the answer is templates. So yeah, I think we're gonna have some fun today. I really want to just do some template metaprogramming, but actually with a real world kind of like an actual real backing application. Refactor what we've got and then maybe add something a little bit more complex. So I'm just going to go to like source game. I'm just going to call it like transforms.h. Might change that later. I will almost certainly not because I'll forget, but I'm basically going to start mocking out what I think we want. So I mean, we might need lambdas, we might need ranges, but I think we'll start off with templates. So what I'm thinking is something like struct. What have we got? We've got like move. Still got like a move transformer, okay. And then this will have a static auto handle vector 3, okay, and this should produce a vector 3. So the idea is that we're going to want to pipeline this. Actually, it's also going to want to take in like a const vector 3. Hang on, do I need to be in a namespace? Am I not namespacing? Oh, Bistra, that is some Windows specific like string implementation. I haven't used Bistra in years. Anyway, just delete all that, didn't want it. So vector 3, I don't know, like in. I think we're going to get to produce like a delta. So the idea is that it's going to go through this pipeline and it will produce eventually the translation that the barrel needs to go in. So if we wanted it to just remain the same, we could just have one transformer that always returned a 0 vector and it'd be fine. So this is going to want to, so in fact, let's just, okay, and let's get up our camera object transformer for reference, because we basically need to do this. So this is static, right? So what we can do is we can basically just always 3. So this is not the final logic, right? But you can kind of see here what I'm getting at. We would take in a thing and then return some transformation on it, and then we will just kind of pass that down the pipeline until eventually we end up with our final delta. So what I'm thinking is probably something along the lines of like template class dot t, okay, struct chain, and then so this is going to be base template, and the idea is that we will just pass it in these, okay, and then because this is static, we won't even have to instantiate the object. As long as we pass in something that has a handle method, we can probably loop through and pass that along. Ideally, I'd make it const expr, but I'm not sure if that's going to be possible because we'll eventually have to do some maths, and not all the maths is const expr. So I'm just going to leave it off for the moment. C++ 26. Okay, so let's specialize this. So I'm going to use the kind of classic head, like recursive peeling off of template arguments to access them all one by one. So struct chain head tail. Okay, and then in here, I think we're going to need like static auto go or something like do. I can't use do because it's a reserved keyword, but something like go, something that gets us going. I'm happy to change the name later. I'm kind of just reading a lot of this off the top of my head. Const vector 3. So this will be the initial like starting vector, I guess. That's gonna be like that. Okay, fine. So we've got something like this. Okay, and then this will return. Basically, what we've done is we've peeled off. This will make more sense when we instantiate it, but this will peel off the first of the packed args, right? Which gives us access to whatever head is. This is just a type, so it could be move transformer. So we should be able to do something like well, you can definitely do head handle in. Okay. This will work. Okay, so this will take this type. So same we passed in move transformer, it will look for a static method called handle, and then it will call it. So this will call this, but then what we need to do is we need to pass that on to the next handle. So I think we need to kind of recursively do chain tail dot 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 go in. Okay, so what this will do is this will call handle, but it will first let's check I get this right because it's quite easy to get it the wrong way around. This will evaluate handle, but it will only call it on whatever's next in the chain. Is that right? I think that's right. Actually, no, I've got a feeling that's wrong. Let's just do const auto like next equals head handle in. Okay, that will calculate the next value, and then that needs to, okay, here we go. Okay. Then that will go into chain go. So chain tail go next. There we go. So that should peel off the first one each time, calculate it, and then pass it on to the next one, because this will then just unpack again, and we'll go back round and it'll take the first one off. And then we'll need like a base case. So I think template class head. So if we instantiate the chain template with just a single parameter, then we'll end up with here, and then we do something like static Hello, Will. Let's try this. Vector 3. Return in, because it's the last one. Oh no, wait a minute. Sorry. Return head handle in. Okay. So I think that's like kind of the mechanics done. What we'll do is we'll construct some tests, because our unit tests as they are won't compile, and then we'll basically start testing this out. So source test test cmake. Let's get rid of these. It's gonna be fun. We're gonna do some template debugging today as well, which is always fun. Well, this is it. Like template metaprogramming is basically functional. You're just working on a type system, and you can't really have functions with side effects. So it's basically functional programming, which if you're into that kind of thing is pretty cool. Right, so tests. So let's just do transform tests.cpp. Let's get up a test so I can remember the remember the runes. I think I need. Is it just gtest? And then what? Test. Transform. Simple. Might end up getting rid of some of these tests, but it doesn't really matter for now. Hash include game transforms. Okay. So let's just go back to this. So much plumbing. Transform test.cpp. Okay, right. Also, if none of this makes sense, do ask questions. I'm not just trying to game the system for engagement by making this deliberately obtuse. It is reasonably advanced C++, but I'm happy to kind of go through it. Also, I need to make sure I actually know what I'm talking about. Okay, right. So let's. If the question is why, then is my wardrobe full of matching white shirts and black trousers? I have a variety of trouser chino colours, but yeah, it's mainly white and pink shirts. I do have a few others, but it's mainly white and pink. I think sometimes I do wear a pink shirt, but I think with the colour of the room, it kind of gets lost a little bit. Great question, I guess. Okay, what I'm going to do is I'm just going to take this transformer out for now, because I want to kind of keep the code isolated. And then what we can do is we can just check this works here, because also we're going to have a bit of a problem as well, because like, how are you going to get a camera in here when it's all just static methods? Okay, let's do so const auto chain equals game chain move transformer go. I'll just pass in like an initial 0 vector. So to Quacko's first point, I will neither confirm nor deny that, but I do plan on not getting demonetized, so you can kind of probably infer what the answer is. Why Google Test and others? I have the most experience with Google Test. I think they're all reasonably the same. I've used Catch 2, I've used Boost, I've used Gtest. I personally prefer Gtest. I don't really have much of a justification other than that. The only reason I'd say Gtest might edge its way out over the others is Google Mock is incredible, and it kind of comes with Gtest, so it's just kind of, those libraries kind of work quite nicely together. Okay, let's do assert equal chain game vector 3 1.0f. Right. So in theory, if this works, it's already... okay. So if this works, then we should take a 0 vector, put it through the move transformer, add 1 and get that back out. I think that would be a reasonably good, like... oh, I bet I didn't set up all my environment variables before. Right. Oh, this isn't good. Hang on, no, I don't want any of this. Right, my dev environment is not set up correctly. Let's just hold on one moment, caller. 4. Right. I normally have this all set up before, so it's all nice. Right, okay, right, that'll work. Okay, tmux, Control C, call this one build, cd into build, and then build. No, that was just because I didn't have the environment variables configured correctly to use MSVC1. I sort of live on a knife edge with this build environment. That stopped working. Sure is fun though. Keeps everyone guessing. That's what everyone's here for. Is the live DevOps. Okay, cool. Doesn't like what am I missing? Transform tests. What have I? Envim. Hang on. Envim. Transform tests. Have I accidentally got the wrong vector somewhere? Okay. Oh, what is that? Go away. Get out of here. Okay, right. Okay, that passed. Okay, so the basic mechanics are there. So what we'll do is we can just do, I don't know, not great. In theory, we should be able to do move transformer. Okay. And this will now be 2. And the idea is basically you can just specify these types, and as long as they have this handle method, then we're kind of good to go. Am I a believer in WinMain? Like, I believe it exists, I just don't believe I need to write it. Let's do, we're doing that, and then we're just going to run C-test afterwards. Okay, cool. Right, so hopefully that makes sense, that this is not a lot of template code, and whilst it might look quite gross, it's not hopefully too hard to kind of wrap your head around. We have a base template, which takes a variable number of arguments. We then define partial specializations of that, which allow us to grab the first element of that periodic list one by one. And then for each one of those, we calculate, we process it, we basically call the handle method on it, and then we pass it on to the next one by recursively sort of popping these head ones off. I think we need a little bit more than this to check that we are doing it in the right order. Okay. Okay. Just trying to think what's one that is what's the word I'm looking for? Non-commutative, so the order matters. Division, multiplication, multiply transformer. If we've even just, I don't know if we've defined that. So multiplying by 2 and adding 1 will be different to adding 1 and multiplying by 2. So let's do add multiply transformer. Okay. So if we add 1 and then multiply by 2, we should end up with 2, right? So we're going to 0 add 1 is 1, 1 times 2 is 2. But if we do where's all my code gone? Okay, fine. If we then do there we go. If we do multiply then add, 0 multiplied by 2 is 0 plus 1 is 1. So this should end up with 1. Not great. Not the best, but hopefully enough to convince ourselves it works. Okay, let's try that. How do I have these tests set up as CMake? What is CTest? So CTest is just a driver of unit test frameworks. It kind of has nailed it. You kind of tell it like, here are my G tests, here are my boost tests, here are my catch tests. You might need a little bit of CMake plugin or something for it, but it basically just drives tests. You don't write. So CTest you don't write your tests in CTest, if that makes sense. You write your tests in your framework, you tell CTest about it, and then it auto discovers them and runs them and kind of does stuff like that. This is the new Windows terminal, yeah. I think it's pretty good. No, we're doing Windows programming, but I just keep it simple with int main. Okay, right. So that's pretty good, and I suspect like the compiler really crushes that down. The issue now is that if we're going to want to rewrite all of these, all of our, let's pick a transformer, camera object transformer. We need access to the camera, but you have to remember these are not constructed, these are static, so these are just called directly without having to instantiate the object, because this would be pretty optimal, right? I don't have to construct any objects. It's just a bunch of function calls and then chaining them together. So the question is how do we pass state in? And I think the answer is to bundle all the state together in a struct and pass it in. No conventional order of operations when the transformers are changed. Yeah, I mean, so my implied order is just left to right. I'm not building like a, what am I thinking of? Like a AST, like a tree-like structure which has a concept of precedence. I'm just going to literally just it's a pipeline. Do I find the tests useful in a project? Yes, I find tests very useful. Tests are kind of part of the documentation, but also I think one of the underrated uses of tests is debugging code. If you have an issue and you can codify it in a test, then you're kind of already on the way to creating a small reproducible environment effectively for that bug. And then once you fixed it and the test goes green, that bug's never going to come back because that test is always there. It might come back in a slightly different form, but that specific bug is not coming back. Okay, so what I propose we do is have like a struct state. It's not, and then we basically take a. I'm going to make it const. Right, and that just means, yeah, basically the physics system has a state struct type thing. So basically anything we need for any of the transformers, we will just stick in here. So for instance, we could have like a const camera, like a reference to the camera. It does mean it will become a bit of a dumping ground, because any transformer that needs any state, it will have to go in here, but I think it'll be reasonably self-contained, and I'm not too fussed about it. It means we don't have to worry about trying to I don't really think there's any other way of doing it other than instantiating all your transformers ahead of time and then passing them in, which is what we've got at the moment, which all involves like, it's all a virtual, they're all virtual, as in like they're all part of an inheritance chain, so they all need dynamically allocating. There's kind of a lot of extra chuff that goes along with it, whereas this is just like type system go. So this will now need a game state. It also means, I guess, kind of no, actually, ignore that. I don't know where I was going with that idea. Those, I guess, will be all unused, so just don't give them a name, and now it can't complain that they're not unused. And then okay, auto state equals. The only problem is that, again, the tests will become a little bit obnoxious in that we will have to construct this state object every time and fill it with every possible thing, and then every time we add something to the state, if it's not default initializable, we will have to modify the tests. But again, I'm not too fussed. Nothing in this world is perfect. And again, this could be the initial position of the object, so that we can even pass that state through. So if we care about if the transformer cares about the absolute position of the barrel as it already is in 3D space, it can start off with that. But I still think it should end up producing like a delta, like the final transform. In my mind, I feel that's better, because if you don't want to move it, you can just return 0. It probably doesn't matter, but that's what I'm kind of going with in my mind. Okay. It is possible to template the tests, but yes, so you can have parameterized tests in gtest. So we could potentially basically say, here's like a bunch of transformers, and then here's the result. I don't know if it will get us what. I don't know if it's actually any better than just writing them out manually. Yeah, exactly. Yes, that's a good point. Yeah, like on Twitch, it makes sense. Otherwise, you need to keep track of the initial position and pass that through each chain. Whereas I think if we just kind of like pass through the initial position, I don't know. Actually, no, because now I'm thinking maybe this always does need to start off at 0, so you can return it. No, you want to pass through. No. No, because you're going to pass through the result. So we have to be consistent with what we're passing through the chain. I suspect it will start off as 0, and then it doesn't matter if we just stick it in the state if we need it. Anyway, I'm getting ahead of myself. Let's keep going. let's just do a quick like struct state transformer. No, actually that's not going to work because I don't want to start influencing the state yet until I have to. Okay, so that's fine. I think the next thing to do is to be able to have the ability to end the chain early. So for instance, if we were doing like a visibility test, whatever that would be, you know, some like visibility transformer handle, it needs a way of returning. It still needs to return a value, okay? Right, it still needs to return a vector 3 because this is how our machinery is set up. But it needs to be able to signify like additional information, like don't go any further. Can't do an optional because that doesn't make any sense because we always have to return the value. So we've got flag, IDs, Boolean state saying continue processing. The thing is though, like at the moment this is marked const and I want to keep that const for as long as possible. It'll be make the code more optimal. I think it will let the compiler optimize it better. What I think we want is something like struct like this, and then be like a vector 3 result, and then like a bool continue. Oh, I obviously can't have continue. Stop. I think the Twitch chat might be more chill just by the fact that there's just fewer people there. I don't know. Maybe we need to pump the numbers up on both of them and we'll see where we get to. Okay, I think that, right? And that way we can always return this, like this has to be returned, but we can basically say yay or nay whether we want to continue. So then we have something like const auto result stop, because we can do destructuring on that. What was it complaining about? Oh, because I've not updated my flags yet, that's fine. Right, stop complaining. I'll disappear. Right, nailed it. And then we can say return if stop return result, else return the next in the chain. I think, right? I don't think that's too egregious, is it? We'll still end up returning a vector. And this will need to be like dot result. It's just now these have to return a game transformer result, right? It doesn't actually matter whether these, let's make sure these are not last in the chain actually, sorry. Okay. I could default it. Ooh, yeah, I guess we could actually default it because that's going to be the base case, isn't it? Most of the time you're going to want it to continue, so that actually makes that code a little bit nicer. Good shout. Okay, so now we can keep passing these through, and basically as long as this keeps returning false, then we will keep going down the chain. Okay, so let's now add a struct, I don't know, like choice transformer. Let's do something like if, no, let's do const auto stop stop. Nope. Gonna get there in a minute. Return in, but the flag will be in.x equals 1.0f, right? So if we pass a vector into this choice and the x component is 1, then it will stop, otherwise it will continue. And I think we should be able to test this relatively easily. Why a struct instead of an enum? I don't. Which struct are we talking about? I think, unfortunately, I've now declared many a struct, and I don't know which one you're referring to. But let's go chain one. So add transform result, because I still need to store the result in it, right? This is just an aggregate type of a result and a bool. It's kind of like an optional that can never be empty, but still has a state attached to it. I mean, you could do out parameters. I just don't really like out parameters. I'd rather things were sort of, again, inputs, outputs, like pure inputs and pure outputs. Otherwise, you end up in like the horror of some of the Microsoft APIs, which are like, on the way in, this argument is this, but on the way out, it will be this. And it's like, great, thanks. I'll just remember that. Sure. I mean, I'll let the compiler pad it how it wants. It's not going to be serialized, so I don't really care. Okay, so let's do, so after add transform, that should be 1, right? So this, if I do, well, not that, choice transformer, then this should be, I'm going to say 1, because it'll add 1, it will hit this choice, and then it won't continue to the multiply. And then if we do it this way, then it will multiply, which will be 0, and then it won't do it, and then it will stay as 1. I think for funsies, we'll add another 1 on the end, just for funsies, otherwise they've got the same value. Any tips to stop leaving side projects unfinished? Stream them. Like, just when people expect you to show up and talk about it, you can't. You won't let you get bored about it. But in all seriousness, it's hard. I think having projects that are small in scope and kind of achievable. If you've got something that's open-ended and never complete, then there's no way you can finish it. So I think it's having more realistic goals about what you can do with your time. And I don't know, do allow yourself to, if it's your free time, there's a bit of a balance, right? Because if it's your free time, you don't want to be doing something that is not enjoyable. So if you're having fun spinning up projects, learning something a bit new, and then kind of moving on to something else, I don't think that's terrible. Like, but if there's a thing you want to do, then it's discipline. Like, motivation will only get you so far. It's discipline. It's like, I'm going to show up and I'm going to work on this for an hour every day, and just pushing through the hard bits and making progress. Okay. Yeah, no worries. Hopefully it's helpful. I'll cut that into a short. A bit behind on the shorts. I could filter these to just run the transforms. Oh, looking good. Okay, I'm pretty pleased with that. Okay, so again, in not a lot of modern-ish C++, I guess, kind of. In not a lot of C++, we can have quite a nice system. So now what we have to do in the next hour is rewrite everything we did to be static handles. Although, I don't know about you, kind of feel this should be a lambda. Controversial, but I think with C++ 20, 23, I think we'll be able to do it. Let's do const explorer auto add transformer equals, especially if they're stateless. Called it. Well, I don't know. Let's see if it works first. That's certainly less code. What do I call it? Like multiply transformer equals that. Have I ever struggled with applications for jobs? I don't like to sound very. When I read that out, it sounds very big-headed because I'm so skilled in my field. I work with a lot of people who are way smarter than me, so it's and I like always have done. I never want to be the smartest person in the room because you kind of stop learning at that point. No, but I think I've always been reasonably lucky to be looking for, I guess, kind of like the right job at the right time. So, and also I kind of like talking to people about C++, so which lends itself quite well to like interview situations. What have I done? All right. Okay, so that I think is actually nicer. I don't know about you. This now won't work because this is no longer a type. It's a thing, right? And you can't, before C++20, you can't put lambdas in what's called unevaluated context. You cannot pass lambdas into template arguments. But as of C++20 or 23, I think it's 20, you can, but it won't like any of this. But what I think we can do is change that to auto, because it's now a non-type template parameter, right? So auto will just happily deduce those for us. And then, actually even nicer, we can just do, we don't even need to scope it, we can just be like, hey, this thing, which is a type, which is a lambda, just call that. Oh wait, have I? Oh, hang on, what have I done? Sorry, you still need to name those. No, I didn't mean to replace the names. You're right. Okay. Oh, all the red just disappeared. That's that bodes well. See what happens. I was thinking about it real hard. Oh, I mean, yeah, look at that. Now that is pretty sweet. I think that's I really like that. I'm really pleased with that. So now all our transformers just have to be a bunch of context per lambdas, and it just figures it out. Could I show your CMake file? Which one? Like the root one is this. Minimum required version, fetch contents, get all the libraries, set up a bunch of stuff at async, and then add subdirectories, and then the actual project one just adds a static library. Jesus, where'd that go? Uh-oh. Hang on. Oh no. Oh no. Hold on. So excited. Sets up a library, adds the directories which just had the files, additional files in, and then sets up a load of compile option flags. Cool. Okay, I'm like really pleased with that. I just, you know what I think might be fun? Might be fun? Hang on. Hang on. Bear with me. Hold on one moment, caller. Output. Code. Right. Let's. Can I just take all of this? Right. Okay. Let me begin this a bit. I'm just kind of. I'm curious how well the compiler kind of understands this. Obviously, it's not going to be totally representative because we're going to have slightly more complex types, but let's just take out. So let's add in these. So I'm just a bit of an indulgence now, but int. Hang on a minute, these are going to need to be a bit further down, aren't they? Below all this. Let's put them here. Okay. That doesn't work. Get rid of that. CT int. And then in +1 times 2. Okay, right. So and I'm gonna print something, but what? If you ever want to print something on Godbolt and not have like horrific explosion of assembly, don't use cout or println or anything like that, because the assembly it produces, whilst I think is pretty good, is because all the template stuff is incredibly complex. If you just use printf, it should just be like a simple like call into the C library. Anyway, so let's do and let's give us what? Where's me thing? Let's go just equals C. This is 23. Okay, so let's do const auto v equals chain. I don't know what, add transformer, multiply transformer, add transformer. Go start off at 1. Stood printf %i. Oh, old school. Right. What's that going to be? So it's going to be 1. 1 plus 1 is 2. Times 2 is 4. Plus 1 is 5. So is that? Was not like. Oh, I need a state object, don't I? Yeah, get that. 5. Okay, right. So hopefully we can all agree that worked. And then I was curious, like the assembly. So it's got all these lambdas, right? And then wherever it's calculating it down here, it should peel them all off and call them individually. Somewhere like, yeah, I can see here, right? It calls the add transformer, then the multiply transformer, then the add transformer. But I'm just like, if you just like really whack this up to like 11, the compiler can calculate it all for you. That is incredible. That is magic. That the compiler has seen this chain operation, realized these are all context per lambdas, and has done the full calculation for us. And it's just like, oh mate, why are you doing all that? Just print out 5. That's the answer. that's pretty sweet. Anyway, I think that's cool. Here's a question for everyone. Do we think MSVC can do it? Give me less options. Give me the one I want. So it's gonna be what, like stud C++ tist -03. I think it's -03. Do we think MSVC can do the same pre-calculation at compile time? The answer will be no. Oh, sad. Maybe I should compile everything with Clang or GCC. Oh, sad face. Yeah, it's calling all the lambdas and doing the chain operation. Oh, that's sad. Oh, come on, MSVC. I'm rooting for you. But 03 will be better, right? I mean, you can try 02, but I don't see that, unless 03 isn't a thing on MSVC. Interesting. Okay. Why am I wrong? Am I wrong? I thought -03 was the MSVC compiler flags. I'm happy to be wrong. Listed alphabetically. Dash. Automatizations. Oh, okay. I'm wrong. I always thought there was an 03. Okay, fine. I stand corrected, and I apologize for besmirching MSVC's bad name. It turns out it is pretty good. Regardless, I'm kind of surprised I didn't complain about an unknown flag. I thought that's pretty cool. I think that's pretty cool. I think the fact that we can, and again, because in our code, vector 3 is const expr. I reckon the compiler can do. Obviously, if it's based on runtime values, sure, but I think that's going to be pretty good. Anyway, I'm glad we, as an aside, that was quite fun. No, I'm only going to try compilers that I'm actually going to use. But that, like, in 41 lines of code, and that's including the empty state struct, right? But in terms of actual logic, in like 20 lines of modern C++, you can build a pretty. This is what I think is like the power of. This is like the power of C++ is you can express your intent with the value system and the type system, right? This is all type safe, and then the compiler, which deeply understands that, can be like, right, okay, I'm going to grind this down to basically nothing. So I think that's pretty good. I'm not an expert in any other systems language. I don't know if any others would be able to do that. I mean, if they am, that's pretty cool, and I'd like to learn. But that is super powerful. Anyway, I'm kind of I've waxed lyrical enough about the terrible C++ templating system. Let's rewrite everything we've got to use this. I think that's basically what we've got, right? So we can take this, and we know what the shape of these are. So let's go back to transforms. I know, right? I'm terrible for it. I kind of think they just stuff all the because they're just lambdas. Well, here's a question: Do the lambdas, which are now effectively tiny, live in the transform header file, or do they live in the game? Like, are they part of the machinery, or are they part of the actual implementation? Yeah, so the chain takes a variable number of t's. These are now auto non-type template parameters, which means you can pass in. This won't work, by the way, if you have a capture list. That won't work. You still can't pass that into an unevaluated context, which is why we still have to have the state. But as these are effectively stateless objects, the type system will accept that. And then I just literally just call it. I'm kind of surprised. So as a C++, 23, you can have static lambdas, so the call operator is marked static. I think it's like here. I'm surprised you don't need that. I guess it's just smart enough to figure it out. Machinery. I've had 2 for machinery, so we're just going to stick them in here. Stick them, I guess, below the chain. Right. So what's our first one? The first one is, okay, well actually, so here's a point. The first one is the static one. Do we even need one from that? Can we... Actually, I have now actually thought of a massive problem, which I probably should have thought at the start, is how do we like save this off? Because all these have different types. I guess each level would just declare them. If you had a level, like a level class, that'd be like, okay, I know I need these. I hope we haven't shot ourselves in the foot with this, because I've been like going off on one on templates. I'm like, oh yeah, but it's not got like a virtual base class now. So what do I do? I think we might just need to refactor this a little bit, but that's fine. Right, okay, so I think I'm gonna get rid of that. And then let's just close this down for a second. Let's have a think about this. So this now needs refact. I think this is now going to go back to wouldn't the base class just become the transformer class once the lambdas on the objects can use in the level? Oh, thanks for coming by, AC. Shame you can't hang around longer. So apologies for starting a bit later. Yeah, catch up later when you can. Quicker, I'm not really sure I understand your point. No, nor do you have to think about it. Let's just keep it simple, because I suspect eventually we will have a level struct, which you just create those levels. I don't know how we're going to serialize this. I am worried I've now actually tied myself to basically building everything in compile time to make the code a little bit cleaner. But, oh well, let's gotta make progress. Gotta make progress. I'm going to rewrite this entities thing for the billionth time. And then I think now that we don't have dynamic allocation, we can kind of go back to this, right? And then this just becomes, again, nice, like AutoMX is so easy because we don't have to worry about the fact that the type's changed. We just have to, obviously we have to change how we handle it, but we don't have to update the types. Can we change the ownership so each entity can have the transformer it needs in a list from the transformer? The problem is though, right, and this is the shortcoming of all this, is what do you store in entity, right? Because these are now all different types for the different combinations of transformers you pass in. So a chain of transformer A, transformer B is different type to a chain of transformer A, transformer B, transformer C. So what type would you store in I wonder if you just make a base class. I'm just wondering if we can kind of, because I want to basically combine static polymorphism with dynamic polymorphism, ideally. So each enters a different transformer. Yeah, but then that's all runtime, right? So I'm kind of losing all the goodies of the compile time. Like, I don't mind. This is all static, right? So this is all, the compiler should be able to figure all these out. What I want to do is basically bridge the gap to the runtime world. Because one thing is something like structs like chain base, something like this, where I can still dynamically allocate this with all the requisite types, but I can. But what's the interface? It's got to be something like, because you can't have virtual statics, so it's still got to be something like. Can you have like virtual auto go const vector 3 in const state equals 0, okay? I'm not entirely no, I bet it's probably gonna do something like that. Okay, so once I had that, and then I made this virtual. Nope, absolutely not. Override. Also, I've just realised it should be vector 3. What am I missing? What is it not like? Any virtual memory functions can be marked override. Yeah, I think it's. Maybe? Do I need that there, or do I just have the missing const? Okay, I do need that. Okay. Something like this, potentially. So I can still specify my chain with variable types, and it will still do the peeling and generate all the members, but it's now that I suspect the compiler might not be able to. If you marked it as final, it might be able to optimize it. Nope. Is it final there? Nope. Okay, fine. Wherever it normally goes. I don't know. Let's have a quick play around with that in the tests, because this is all going to be unhappy now. So chain, and then hang on, let's just do the first one first, right? So okay, so let's construct the class and then do chain dot go I'm not convinced. No. Oh, hang on. It's because I've had a right old go at main, haven't I? Right, let's just bring all this back out a second. The use case of chain base is so that I've got something. Interesting. So the point of chain base is to have a common, like a base type that I can refer to it as. So you have to remember with templates, every time I create a chain with a different set of template arguments, those are new and distinct types in the type system. But if I want a way to refer to all of them and use basically dynamic dispatch, aka virtual to kickstart it, I will need a non-templated base class. So what I've basically said is everything will inherit from chain base, which means I should, in theory, I do need to check this works with multiple transformers, but I should in theory be able to basically do make unique chain blah 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 blah. Struct chain base final. Okay, so final just means that there is no further inheritance from this point onwards. It's the equivalent of sealed in C#. By doing that, the compiler, if the compiler knows all the possible, if the compiler knows 100% the at compile time, the virtual function we're going to call, it can elide the dynamic dispatch, aka the vtable lookup. So it might be able to flatten all that down. I'll get Godbolt out. I'll have a look in Godbolt in a minute and see what's going on. Let's just start uncommenting these. I do not expect the compiler to devirtualize all these. I am hoping the compiler can devirtualize these. I have zero expectation that it will. We'll have a look in a minute. Yeah. I'm not convinced this is going to work through multiple transformers, but we'll see. If this works, it'd be nice because we get kind of the best of both worlds, which is what I want, like expressive compile time composition, but the ability to kickstart that, but still be able to effectively have a runtime dynamic handle to it. Requires an. What do you mean? Where? What? Hello? Yeah, this is the. Oh, hang on. Right. Nah, I see. Okay. Now here is the problem. I will lose the some of the niceties because I will have to now construct a chain, like a new chain, which is the tail ... right? And then do d2f chain dot. In fact, actually, we should just be able to just do chain tail ... go. I think the compiler will chew through that pretty easily because it might even be able to use the. I suppose it won't be the empty base class optimization, but it knows it's an empty class with no state, so it might kind of just work. Anyway, bit of fun. It's better than actually writing a gameplay code. This, I'd much rather rewrite it all using templates. Okay. Right. So let's just rewrite these, and then we'll hop back over to Godbolt, and we'll see what kind of mess we've made over our like beautifully optimized code. So chain 1 is equal going to be to that, and then .go. Because the other thing is we just use composition, like runtime composition. So we just create a bunch of classes which do like things, and then have like a vector of them and dynamically allocate them. I just thought this would be more fun. And this is what I get for trying to have fun with C++. Go state. I do wonder if we are having to no. Okay, right. Let's get this working first before I go on to the next thing. So, but what happens if I rewrite it all doing this? Go. Yeah, I think because all the lambdas are const extra as well, I'm kind of hoping it should do it. No, so tail is the remaining variadic pack. So you have a pack of variadic templates, i.e. more than one. Nice. More than one temp, right? So here we got a pack of 3, 1, 2, 3. Here we got a pack of 2, 1, 2. What this does is basically say, give me the first one and then stick all the remaining other ones in another pack. You cannot index into variadic arrays, at least not yet. I think it might be coming in 26, or there's at least a paper out for it. The only way you can do it is effectively pop the top one off each time and stick the rest in a remaining tail. Yeah, it's head, rest, list recursion. I use head and tail. You can use head and rest. It doesn't really matter. Okay, right. So let's codify up some of this. So I had, what did I have? I had like a struct. Let's just probably just copy all this, right? All the vector 3 stuff. Right. Won't take me long. Chain base. And I'll just copy it. Change mine again. So we need to do %s const vector 3 with int. I forgot to put the space in. Const vector 3 int. Okay. What is it not? Is it okay with that? And then s vector 3 int. So virtual go returns an int, returns 0 int. This takes us to chain base int override type chain base. Yeah, you're not wrong. I did have a go at writing that twice. And then here is the same we've done everywhere else, and that is v dot go 1 state. Did I start off as 1? I think I did. 1 add 1 is 2 times 2 is 5. Okay, so it still prints the right number. don't think it's been smart enough to calculate that at runtime. Oh no, I take it all back. Okay. And that is MSVC as well. But okay, so even despite that, so here's the thing: is it smart enough to do it through? Yeah. No, let's say Daniel's got it. Is it smart enough to do it polymorphically? So let's do auto test, taking a chain base chain int, right, and then return v go one base, right? Not v. So now what the compiler will have to do will be like, oh, this is a base class. I will now need to go and look up. I now need to go and find in the v table where this go method is for this particular base class that you passed in. So let's do test v. Shall we still get that? Right, still get the right answer. Let's go down to here. Okay, yeah, it's not been able to calculate it. It's had to call the virtual method, which is, I mean, it's no great shakes at the end of the day. Is this? It's not the end of the world, because none of what we're going to be doing we're going to be able to do at compile time anyway, because it involves user input, like things that the compiler can fundamentally not know. I was just curious, like, what you lose. Let's have a quick look at GCC. Again, I still think the flexibility we get is better than not. Oh, GCC. How very smart of you. You've managed to devirtualize it. That is incredible. So it is possible. So I'm pretty pleased with that. I think we can kind of get the best of both worlds. I'll tell you for free, the problem we will have, but I'm not worried about now, is if we want to serialize any of this to like a file, there's literally no way of turning a file into template arguments without code gen. So but yeah, okay, I'm pretty pleased with that. I think that's good. I think we kind of, and actually this now makes main so much easier, because now we just have a unique pointer of hang on. Get out of here. What are you doing? Nope, take it all back, I need that. Include transform and have a game chain base, right? Which will be our, I'm going to call that a transformer chain, because I think that's maybe better. Why is it not? The transforms thing. You prefer the virtual call over template functions for chains? Is that like a, you asking, I don't understand the question, sorry. Are you asking my personal preference, or is this a clarification of what's going on? Okay, so now we should be able to place back a make unique. Let's just. Okay, right. So now that I'm happy with this, we can go back to the original question I was posing. Why use virtual base instead of things that need to be called chain? Because I want to be able to store one of those chains with against the entity, and I don't know how to do it with the templates. Maybe there's a better way, but I can't then stuff these in a struct and a vector because they'll all have different template arguments. So I kind of need to bring it back to the polymorphic like code at some point. Yeah, but then I couldn't store those in a vector, right? We're just pushing the problem further and further away. Shouldn't you also start getting rid of the command line args? Possibly? No, at the moment we still need to know where the asset file is because it's not embedded in. So yeah, the thing is though, is we could template transformed entity so it passes those template parameters down. Yeah, I know, that's what I'm saying. That is it, right? I'm kind of happy just to go via dynamic dispatch for now because it fits into the code we've already got, where we've already got these list of entities, we iterate over them, we use ranges to pull out the addresses. I'm kind of happy to pay that price. I think what we've got now is a pretty good middle ground between compile time flexibility and runtime, like compile time composition and runtime flexibility. Oh, I don't want to do type erasure. Like, just stick it on Studeni and hope for the best. Yeah, as the cost is minimal anyway. Anyway, if it's a total disaster, we'll just go back. But I think what I really want to get to is where we can write small little lambdas which do something interesting and chain them together, but have that fit into the existing machinery. I think this is okay. What you could do is have like an even more base template. Like which just returns in. What am I doing? So now our static non-moving one, right, is basically just the empty chain. We don't even have to create a lambda to say, hey, don't move around. I think we can probably test that out. If I say make game chain why are you doing? You expected an expression. What have I missed? Need to compile to get the header. Yeah, I should pick it up though. Anyway, let's just fix what's almost certainly going to work down here. So we no longer need to do transform update. What we do is do const delta, entity delta equals transform arrow go, and then put in here. No, we decide we I think we don't want that. I think we're going to have to pass the position into the state. Oh, what is going on? Right, entity. Set position, set rotation, auto translate const. Vector 3. Translation. Void. Yeah, that's what I'm going to do. That's what I'm going to do. I'm just making sure it's in this now. I am using exceptions. I mean, I'm not like right to this second, but the code base does use exceptions. So transform dot position plus equals translation. I think that's right. Okay, fine. So I just added that quick, and then we go back to main, and then we do entity dot translate entity delta. Okay, and then we don't need any of this. And then we had a light on that position, didn't we? So we can then do const auto position equals entity dot. Doesn't have a. How do I? Yeah, I'm sure I'm missing some context for us. We'll go back and sprinkle them in a minute. Good point. I don't know how to get position. Like, I guess I've just because I've not needed one. Doesn't entity const? Oh, it does. Amateur hour. Return transform dot position. Okay, fine. Entity delta transformer. I don't know why it doesn't like this. There should definitely be a reference to the unique pointer. But anyway, equals position, right? And what we're saying back in I'm so glad I have transformer and transformer. Oh, transforms. Right, okay. We think this can be const expra. I think you are right. Nice. Okay. In fact, that is wrong. It's not wrong, but I prefer it there. Okay, fine. Let's just see what makes the compiler unhappy, shall we? Yes, it is Telescope as the file previewer. Okay. Oh, because it's not. This all makes sense now. I see what everyone was saying. This is now in. Sorry, I missed. I think someone even said this. It might have been Queco. Right, so if we now do source game assets, hopefully this continues to work. Nice, nailed it. Okay, right, so now we want to do this one, right? So this is the what have I? No, not this one. I think I've gotten these a little bit confused, but it's not the end of the world. Let's make that there, and then we're going to have the one on the right, which was what we had before, be the camera object transformer. Right, so here's where we can get fun with it. Oh, Acid, go away. What are you doing? Get out of here. Camera, okay, and then we can have what? Const camera ref. I tend to avoid const and members in that, but we're just passing around by reference anyway, and we're not going to copy it or sign to it anyway. Yeah, we've built our own vector class, we've got our own transform class, we've done most of the maths from scratch again because it's just as interesting parts of C++ kind of within that. I will need the camera, so the question is, do I need the whole camera or just the position? We will need the whole camera later because we'll need to construct a view frustum from its view matrix, from its projection matrix. So it's easy just to pass the whole thing in. But it's a good point. I believe this means now all of our... So I'm kind of tempted... So the perpetual question, do I make the code easier on the tests or not? So this has to have a camera, right? It's a reference, it has to be bound to something, you cannot instantiate it. But if I just made a pointer, then and in fact and default initialized it, all the tests will continue to compile and work, and I just pass the pointer to the camera in when we do it. But I will always have the camera there. So having a point, so the API I think is kind of wrong on one sense, because if I always have a camera, it should be a reference. On the other hand, it makes testing a massive pain because every time I add a reference to anything, I have to make sure I can construct one of those in the test and then construct it. So what am I thinking? In fact, actually, that's wrong anyway. I want that. But it has to... You can't have a reference and an optional, at least not yet, not until they decide what they want to do with it. And it has to... I don't want to put a copy of the camera in, right? Or you template the state. Oh. Oh no! Now he's said it. Let's just. I'm not saying I want to do this, but Yeah, I mean, I don't want to write a dependency injection framework. I could use Boost DI, but where's the fun in that? I'm not saying this is right. I'm just saying I'm trying it. Oh, mother flipper. Okay. Trying is the fun part, sure. You can definitely have two variadic template packs. I have no idea what this is chatting on about. I'm going to see what this VC says. Let's just keep going. We're kind of committed to the templates now. So what's a few more templates between friends? I think this will no longer work because I don't know how it's going to disambiguate between. So it is classes, not non-template type parameters, non-type template parameters, whatever that one is. Oh, steady. Anyone out there enjoying themselves? Okay, right. Back to the tests. So I should be able to do an S game state with test state. Fix this one up here. Just going to close that down so I can see what's going on. Right. I mean, obviously. Oh, thanks. Also the temporary back. It must appear at the end of the I wonder if you just can't. I suspect you can't do. I wonder if this is a limitation. I'm not a template expert, but I wonder if you cannot mix these two together. Yeah, like if that was another class, as in a type template parameter, then it would work. You can definitely have multiple variadic packs. You probably can't have one. Well, no, because doesn't also only deduce. Template auto parameter. Auto end. No, I don't think auto includes class because I think auto is only for the non-type template arguments. I can actually find a lot of uses of auto here. Template parameter auto. Declaring non-type template parameters with auto. So that was a feature in C++ 17. Yeah. So it should. I don't understand why you can't mix the two of them. How's it going? It's just template errors now, so it's going okay. Maybe you can't do it. Maybe you cannot do it. And type. Yeah, I don't know. I'll see if Google gets it. Do I need S to be variadic? No, because I could just wrap it in another state object. So you could define like game state, right? And then just template state on that, and then have access to that. I want to just see if I can make this work, because I kind of just feel like it should work, but I think we're right. I think we're right at the limit of C++ templates now. A pack is a C++ entity that defines one of the following: a template parameter pack, a function parameter pack, blah 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 blah. Template parameter pack, a structure binding pack. What's that? Oh, cool. Anyway, getting distracted. A non-type temporary pack with an optional name, a type constraint type. Pack expansion. This is basically what we've been doing. Template argument list, template parameter list. Can't find anything that says you can't do it. Yeah, pack indenting, that's C++ 26. Oh no, maybe it's just not possible. What's the actual template error say? If a class template, oh god, it's gone. If a class template has a template parameter pack, it must appear at the end of the template parameter list. It does, like, it does appear at the end of the list. Well, I'm trying to just. Oh, do I? Yeah, I just. Yeah. I'm very reticent to ever consider something a compiler bug. However, let's boil this down to what is basically struct. So what I've got. Template auto t class s struct food. Right, that's basically what I've got. Interested what the other compilers say. Parameter pack team must be at the end of okay, fine. So both GCC and MSVC. Come on, Clang. Come on, Clang. All think it's the same. Give the same error. So I'm inclined to think. Anyone? Anyone? Someone just tell me. Auto. I don't think. Oh, interesting. So they've got it there with a specified one. So actually, that's a good point. What if I just was like, oh, just give me some number of ints. Still the same. Finish compiling. Alright. I'm just missing. Am I just missing something? I could have sworn you could have multiple parameter packs. Oh, can you do that as part of a partial specialization? I bet you can. I bet you have to have something like. No, I know when I've seen it before. So something like class T, class V, right, and then have like template class T dot class dot V, and then like struct foo template class dot T struct pack. Yeah, I'm thinking tuple. Yeah, so if you have a variadic pack, for instance, like a type, this is like a type list, and you template it on two type lists, or two things that are themselves going to be templated with variadics, you can then pull them out separately on a partial specialization. That's what I was thinking of. I don't think that's going to work. But what I think we can do is just keep it simple. Just do class T, and then just have like a T state, right? And then I'm going to call this S just to be consistent with the rest of it. S, and then we can just drop all these off. So that's 3x. So dot. Oh, has it still got to be the last one? Right. I spent more time on this than I needed to. Oh no, I can say at the end because I can just do S like that. Right. Okay. Okay. I'm not sure if this is any better. Well, I don't think we're going to be rewriting many of our operations today in chains. Oh, mother. Okay. Is it? I'm trying to make a... It's basically the chain of responsibility design pattern where you have a chain of objects that each do some sort of transformation and pass it along to the next one, but any one of them could at some point decide, no, we're done, dropping it out of the chain and return the object early. But I was trying to do it all with templates so that you kind of have this nice compile time list of things that it goes through. Maybe, I don't know, I'll have to have a look. Okay, so now here, so now we can have struct, I don't know, game state, game transform state, and this can have a const game camera, and then we can template this, template on game transform state. And then down here, we're going to do, before all this, we'll do auto state constant equals game transform state dot camera equals camera, and then go state. I think this isn't going to work. I think we might just do it. Is it state first? You sure it's... I thought it had to be first in the template parameters. I didn't think it was first in the actual argument parameters. But I will just check. No, it's definitely second in the parameters. Oh, hang on. It's here, isn't it? That's why. That's why. Okay, right. Now we're going. I think the tests might be unhappy, but that's fine. Well, it looks like it's, unless the compilation bombed out earlier, it looks like it's, ooh, what was that? Main, here we go. Ugh, reason cannot convert from const game state to game state line 238. That's... no, I haven't even thought about ECS yet. I'm just trying to get my templates to work. Oh, hang on. That's why. Because you need to wrap it, don't you? State is actually a game state. Yeah, you're right. What am I doing? So that's going to be done that, and then here we go. Right, dot state equals Jesus. Dot camera equals camera. Right, there you go. Easy, obviously. Yeah, basically, I'm templated the state on the actual game state and then storing that in there. So I had to make sure I constructed it in the right, so I had the right shape. I think we're finishing soon. Okay, main seems happy, assuming they actually tried to compile it. I think I saw it that it did. Okay, so transform tests. Oh, Jesus. Equals game state struct. What am I doing? Struct empty state using game state empty state. Okay. Okay. And now this needs empty state. Right, now we're getting there. Now we're getting there. We could actually alias this, right? Because we could just do template class T using test chain equals game chain test state T dot dot. And then an S game chain becomes test chain. Nope. Yes, 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 yes. Oh, now I've got to undo what I've just bloody did, haven't I? Is that right? I could have sworn that was. Maybe I got ahead of myself, trying to simplify this even more by making it infinitely more complicated. Yeah, we could have just like a default null state as part of like the machinery. I'm just trying to get this to compile again. I blame Daniel for saying I just needed more templates. Cannot convert from test state to game state S. Let's just fix one template error at a time. Just one template error at a time. That's all I ask for. Test state to test state. Yeah, if I like, well, hang on. This is just a templating area, right? No matching type for call to object constant. If I probably not. Cannot convert from test state to const game state S on line 27. Oh, so it is here. Oh, hang on, wait a minute. You've got to have the unwrapped one here, right? Yeah, yeah, you do. Ooh. Ooh. Some template misery today. Love it. This is what it's all about. That's what it's all about. Exciting template programming, right? The test passed, so like, what more could we want? Source game assets. Right, nailed it. I just want to super quickly write one of the camera ones, just to kind of prove it works. So test transform tests. I just can't remember. I was like, oh, this syntax is so simple, it's great, and I've already forgotten what it is. Right. No, they're gonna have to be, unless I template the lambda. No. Getting ahead of myself. I need access to this transform state now. So enough template. Yeah, okay. Even I will agree that we've had enough templates, and I am slowly just digging myself a templated shaped hole. So at least be the right size. Delete called on non-final answers, virtual functions, but non-virtual. Oh, it's just complaining about something. It's fine. I'll fix that later. Okay. Will the state always be immutable? Yes, I'm hoping it will be. It's more of a way of passing parameters in than none of these should have any side effects. So the plan is for them always to be immutable. I hope. So let's do camera move. Okay. So test state. So this is going to be const game transform state. And it's gonna be, what's it? Const. Hang on. I have this somewhere. Oh. Because I'm not tracking the last position anymore. Yeah, I just think what we're going to need is game vector 3 entity position, right? And then we can do oh shit. Have I done all this work just to realize that actually I do now need mutable state? I need last pos of what the camera. Game vector 3 last camera pos. Yeah, I think I'm going to take this on as tech debt for the moment. So we don't actually need the. So we will do in turn. It's actually more like camera delta, isn't it? So we will take the previous input and we'll add to that the state.camera.position minus state.last camera position. Right. And then what we'll do is we will take this out of here before we start the loop. Make it make this mutable. All right, and then dot last camera position equals camera dot position. Last camera pos. That's right. Last camera pos. All right. And then at the end of the loop, so after we've done all the processing, before we do the next tick, we will do state dot last camera position equals camera dot position. I think that's right. And we're going to find out. So then we add back our into here, and then this has chain. And camera delta. Okay. I really must wrap this up in a minute. Right, okay. What's it like? What's it like? Cannot convert from constant state to const transforms line 52, main 47. That's what I want. Hey, no worries. I'm glad you're enjoying it. Wait a minute. Isn't this the exact problem I just had in the tests? Don't these need to take a const? Oh, this is getting a... What started off as like a beautifully simple solution has actually exploded out in complexity. And now these are going to be state dot. State dot. Just thinking about it. Oh, it's basically complaining that one of the base classes has a non-virtual destructor despite being virtual, which just means there's potentially a memory leak. If you pass it around as the base class, then call delete on it, it won't know that it has to call a derived destructor. I mean, still works. Right, I really must go. But I'm super into this now. One more thing. I really want to. I think we can do something really even cooler now. Right. Yeah, exactly. We can just take the whole point. This is why I knew in my mind there's a reason I wanted to pass deltas in. We can just invert the delta for the next one. So if we go down now and we do like, just add another one in, right? Stick it in minus, do camera delta, and then we'll just stick in the invert. What did I call it? Invert? The game state T wrapper. To be honest, I suspect the way I've iterated on this, it could potentially be simplified. Yeah, I think you're right. You could just pass in a T by reference. There's no need to wrap it in the state anymore. I think we'll do that next time. But that is so nice. I must admit, I am super pleased with that. I know we've finished exactly where we started, but we sure did write a lot of template code to get there. And really, is that not what it's all about? Like, I think now, there's nothing stopping us doing some cool stuff now. We can just chain together loads of stuff. We'll definitely do something based on the camera next time. Yeah, I think the machinery is so much better. I'm really pleased with that. That is kind of, in my mind, when I was thinking about this in the week, and I was like, this is where I wanted to get to. This is really nice. And again, we could have like a occlusion test here. And if you can't see it, just don't go any further. Yeah, and I think we can definitely simplify all this, but next time, because it is now 10 to 11. I have work tomorrow. There's a beer with my name on it in the fridge. Hang on, where's my button? Why is that shrink the window? What's it doing? Weirdo. Is that what's happened here? Why have I lost half my chat? Anyway, hopefully that's satisfied you. Yeah, thanks everyone for coming along, much appreciated. What we'll do on Sunday is more of this. Now that we've got a bit of a better framework set up, I want to just smash out a load more of transforms into something fun, and then I don't really know where we're going to go from there. We'll probably have to make a level at some point. Thanks so much for coming along, and I'll catch you guys all Sunday.